How to build a model steam engine part 43. In this one I'm going to show how I make the eccentric sheave. I machined the eccentric strap in the previous episode, and here is a short extract from that to show how I did it. As you can see, the gunmetal eccentric strap is mounted onto what's going to become the eccentric sheave. Once I'd finished using this piece of steel as a mandrel to allow the eccentric strap to be accurately machined, I turned it around in the chuck because now I'm going to machine it into an eccentric sheave. One thing I forgot to film was the fact that before I removed the piece of steel from the chuck to turn it round, I set the position of a parting tool against the piece of steel that I machined for the mandrel, and by making a note of the numbers on the hand wheel, I can now machine a wide groove of a diameter that will perfectly suit the eccentric strap. At this stage I'm going to mention that I am not making this part like it is on the drawing. Either way, the process is very similar. I just prefer miniature locomotive type eccentric sheaves because they have a larger bearing surface. Normal Stuart eccentrics either have a groove machined in the sheave or a groove machined on the inside of the strap. But I believe that the design of the eccentrics for a Stuart engine reduce the bearing surface area so they wear out quicker. Miniature steam locomotives are far more brutal than a stationary engine, and they run a lot faster generally, and that is my logic for making the eccentric sheave the way that I'm showing. Just for the video, I've moved the position of the eccentric sheave in the chuck. It's not fully machined to size yet, so it's not important. Very shortly, quite a lot of the material of the eccentric sheave will have to be machined away, and you could part it off, but that's a bit of a problem. Please keep watching because I'll explain why later on. The outer edges of this eccentric sheave end up being quite thin. In this clip I'm facing across the front. This will size the first of the flanges that hold the eccentric strap in place. The two outer flanges that are left after I machine the groove are quite thin, only about a 1/16 of an inch. You could make the eccentric sheave with thicker flanges, but then it's going to look ugly. I always try and keep as many parts in scale with the engine. And even though this steam engine is not a scale model, the eccentric sheave will look much better if it's not large and clumsy. What I've just done is widened the groove. It's not fully turned to the right diameter. The sheave is turned to accommodate the thickness of the eccentric strap. This next part is critical. I've marked out the position where I'm going to drill a hole to fit perfectly on the crankshaft so that the part does then become an eccentric sheave. You know the saying, measure twice and cut once? Never was it more important than in this clip. I misread the drawing. I thought that the distance from the centre of the eccentric sheave to the part where the crankshaft goes through was 9/32 of an inch, but I got it wrong. Sometimes when I make these videos I'm too busy messing around with the camera, getting the angles and lighting right, and in this case I misread the drawing. Here's take two. I soon figured out that I'd got it wrong. The distance between the centre of the eccentric sheave and the centre of the hole where the crankshaft is going to be is 9/64 of an inch, so I quickly corrected the problem. I'm glad I spotted this because if I'd drilled the hole on the original line, then this part would have been in the scrap bin. The eccentric strap is a little bit of a tight fit on the sheave for the simple reason I removed the solder. I've mentioned this in a previous episode. But it's not a problem at all. I'm just going to use a piece of gasket material in each of the gaps. I mounted the part in the machine vise of my drilling machine and drilled a hole using a centre drill exactly in the place I need it. In this clip I'm just checking how the eccentric strap fits to the eccentric sheave, and it's a really good fit. Which, to be perfectly honest, with my engineering skills, this is a bit unusual. Normally I build in wear by making the parts a bit of a sloppy fit, but not so with this. It's quite accurately made. And using plenty of oil, I ran it for a while in my small Myford lathe and held the eccentric strap in a stationary position using my Barco spanner. This started to bed in the parts, and it's always a good thing to do. To drill a hole in this eccentric sheave, which will be 1/2 inch in diameter, I'm using the 4-jaw chuck. And this is just one example of how long it can take to get the pre-drilled hole to run concentrically. It took a lot longer than this. And what you mustn't do is run out of patience, because this can be a very fiddly job. In the end, I got the hole where I needed it to be, and the centre drill fitted it perfectly, so I drilled it a bit deeper and then used the twist drill to go all the way through. I did the job in stages though. This drill bit is about 3/8 of an inch in diameter, and this one is a bit bigger. And the final drill bit that I used is 1 imperial size less than 1/2 inch. You will notice that the lathe is running very slowly for this job, and it's still going to be running slowly for the final part of the procedure. This is a reamer, and I'm going to push this through the hole very slowly, and it will cut the hole to exactly 1/2 inch in diameter. And when this final part of the hole manufacturing is complete, then the crankshaft should slide into the hole very smoothly, not tight and not slack. You can insert your own girlfriend joke at the end of that line. When reaming, it's quite important to run the lathe slowly and also feed the reamer in slowly too. I used plenty of WD-40 when I did this job, and as you can see, the finish in the hole is quite good. After I'd finished reaming the hole, I pushed the crankshaft into the hole and rotated it. And the good news is the crankshaft ran very truly. Time now to change chucks once again. Normally I use 3 machines, so I have a different chuck on each machine, but I wanted to do all of the job on this lathe, which is a bit bigger than the Myford and not as big as my Smart & Brown. Now I need to remove quite a lot of metal from the part finished eccentric sheave. You must not do it this way. The thin flanges on the edges of the eccentric sheave are too thin to be held in the chuck. And this is even worse. If I turn the part round, I could, I suppose, use a parting tool. But there's going to be a major problem when the parting tool breaks through into the offset hole in the centre. It will just snap off, and the part may be ruined. Whenever you see the red X, that means do not do it this way. Please heed these warning crosses, because I put them there for a purpose. I machined a little bit away with the parting tool, but not enough to go through into the hole. Before going any further, I need to drill and tap a hole so I can use a grub screw to fasten this eccentric sheave onto a piece of 1/2 inch diameter mild steel. As always, I start off with a centre drill, because that doesn't wander about much, and I follow the hole made by the centre drill with a tapping size drill bit for 4BA, which is 3.1mm or 1/8 of an inch. To aid the threading process, because I don't want to break the tap off in the work at this stage, I'm using some metalworking spray. I don't know where I got it from, but it's quite a good lubricant, and I use it frequently for jobs like this. For general turning, even though I shouldn't, I use WD-40, because it's not quite as messy and it evaporates. In this clip I'm fitting a grub screw to tightly fasten the eccentric sheave onto the piece of steel bar. I'd better mention that this is not the crankshaft. It's the same diameter as the crankshaft, which is 1/2 inch, but it's just a piece of scrap out of my scrap bin. Doing the job this way is quite safe. The eccentric sheave really can't be damaged unless you're entirely stupid. But the order of the day is take light cuts and check frequently how close to the flange you are, because you don't want to accidentally machine away the flange that holds the eccentric strap in place. Here is the finished eccentric sheave, which just needs a bit of a clean-up. I slackened off the grub screw and removed the piece of steel. A bit of the casting sticks out from the eccentric strap, and this is to allow for the attachment of the eccentric rod. All I'm doing here with the part mounted in my milling machine vise is squaring it up. The milling cutter's a bit small, but I'm too lazy to change it today. Plus, I suppose if you use a small milling cutter, there's less chance of it doing major damage to the part if it catches up and breaks. After the milling operation comes the needle filing job, just cleaning up the part. I will be cleaning this eccentric strap more than this when I get nearer to finishing the engine, but here you get the idea what it's going to be used for. A piece of steel bar needs to be drilled and bolted to the eccentric strap, and this in turn will drive the slide valve's rocker arm. In this clip I'm assembling the eccentric strap and the eccentric sheave, not forgetting to put some oil in it. When I tighten the nuts on the bolts fully, it's a bit tight on the eccentric sheave, but when the engine's finally finished and it's run for a while, you will be surprised how things free up. For the final assembly, when I build the engine up, I'll just fit some temporary packings. And that is it for this episode. The eccentric strap is finished, the eccentric sheave is finished, and here they are on the crankshaft with the crank web and the flywheel. I know that these episodes about the eccentric strap and sheave have been a bit long-winded, but this is a really important part, and it's very easy to make a mess of it. Stay safe, thanks for watching, and I hope you found it useful. Please take the time to visit my Miniature Steam Models website and click on the section of the website that says Video Playlists. And by doing that, you can find other videos that you may like to watch. And by using the playlists, you can actually watch the videos back to back.